Hello, and welcome back to Nerdsniped, presented by Seedplex. So Nerdsniped is a series of videos that I'll be doing on advanced blockchain topics that have nerdsniped me, and hopefully now you. The first of these videos we're going to be doing on Arcium. If you haven't seen the first video I did on Arcium Basics, I highly suggest checking that out. In that video, we explored what a privacy protocol like Arcium does, and why it's so cool that in the design space that it opens up for new projects. That design space is what this video is about. In this video, we'll cover what encrypted confidential computing means and what are the cool things that you as a builder can think about now building now that you have this tool in your tool belt. So without further ado, let's get started. There we go. So encrypted confidential computing. In my personal opinion, it is the biggest design space expansion in blockchain technology right now. It is one of the coolest things that I've been seeing, and the reason for that is not just because of what it is, but how it's implemented. Arcium went out of their way to build as a network extension on top of Solana. This means that you can use all of that public liquidity, public access infrastructure on Solana and add all of these new tool belts. A lot of the other encrypted frameworks that I've seen, I'm not going to necessarily name them, but they've deployed as other L1s. I don't want to go build somewhere other than Solana. I don't want to go build somewhere where there isn't as much liquidity or there isn't as much developer ecosystem. So now that we have this extra tool belt on the Solana blockchain, we get a massive, massive, massive new design space that we can play around with. The first of these is confidential or dark DeFi. I have a whole slide on this in just a little bit, but basically this is privacy transactions, whether you are holding encrypted token balances, whether you're doing order book swaps and things like that. Keeping all of that information private, such that you have no leakage on MEV or anything else like that. Second really interesting thing that I don't think a lot of people think about or talk about in the blockchain space is private AI or decentralized machine learning. So we'll talk a little bit about this. I have a whole slide on this as well. Um, but basically being able to train models with encrypted data. The third one is governance. So, one of the hard parts about public blockchains has always been, hey, as a public blockchain, I'm taking all of this content, all of these votes, and I'm putting them on a public blockchain. How am I securing all of this? So now you can do private governance. You can do voting without letting people know what's going to happen and things like that. Larger compute workloads. So because Arcium operates as its own MPC network, Solana is restricted by the compute limits on the blocks because all the nodes have to be able to quickly, within 500 milliseconds, be able to do all the compute in a block. Well, because of the way Arcium works, which is you queue up a transaction, that compute goes off, goes and does it in a circuit, and then comes back as a callback. You can do much larger and much more interesting computes. So you can do computations that are like shuffling cards or doing encryption and all these other cool things, which allows you to do, separate those concerns out of what is happening on Solana and what's happening in the MPC network. And then finally, number five, actually not finally, because there's probably a lot more design space that I haven't even covered in this video that probably gets opened up that I don't know about. But number five is non-determinism and randomness. Now, one of the constraints of a public blockchain like Solana is that it has to be deterministic. What that means is, given a set of inputs, it always has to create the same output. Because Arcium is not a consensus layer, Solana is the consensus layer, the transactions going into Solana have to be deterministic, but transactions going into Arcium do not. And what that means is you can do things like random number generation inside of Arcium nodes. And because it's an MPC network, multi-party compute network, you actually have security on that random number generation right out of the gate because the way the random number generation works is you have multiple nodes that each generate a random number. As long as even one node is honest in the n nodes, dishonest majority, um, the random number that it generates will be truly random because they all get added together. This is really, really cool because now you have access to random numbers on chain. That's not a thing that we had before. We had things like verifiable random functions and we had things like Oracle provided randomness. But all of those were kind of clunky. As a developer, I didn't enjoy using them. But with Arcium, I can use those inside of compute and do all of these really interesting things all within that one workload. So let's talk about confidential DeFi. That's probably the biggest topic that most people in blockchain care about. And so here are some examples of how privacy preserving financial transactions can massively expand the scope of what you can build on chain. The first, you start with encrypted token balances and transfers, right? This is kind of basic. How many of what token do I own and who am I sending it to? That's kind of simple. We could do that with ZK. There's been technologies that kind of take care of that. The second step down is encrypted trades, encrypted matching, advanced compute, order books. Now you can submit transactions without MEV. You don't have targeted liquidations because you can take perp positions without someone knowing, that you're taking a specific position and that needs to get liquidated at a specific time or all of these things. You get access to state in a way, you get access to compute and state in a way that is privacy preserving and doesn't do leakage to malicious users that are trying to hurt you. You can build hidden prediction markets where the odds are unknown because current prediction markets, people generally say, okay, well, if it's 90% more most likely to happen, I'll just kind of pick that 90% as a safer bet. Well, you could build hidden prediction markets where people are like, okay, I'm going to pick this because I think this is most likely to happen, not because most people are picking this. And that's kind of a cool kind of mechanic. You can build blind or dark auctions where what other people are bidding is unknown. You can, and this is my kind of personal favorite, do hidden socialized wins and losses, or what we call unstable coins. I don't have a slide on this, but this is going to be my Cypherpunk hackathon project. We're building an unstable coins payments app called DGen Cash. And so I'll have a whole video on how we've been able to use Arcium to do socialized wins and losses through mechanics of custom mints and burns on a token, which is not something that we could generally do on Solana with a coin pegged to stables, but we can in Arcium because of some interesting mechanics that we get access to. Again, for these kinds of things, if you're interested or excited, leave a comment so I know what I need to deep dive into and kind of explain further. But I'm trying to keep these videos a little bit shorter. And so if there's any specific thing that caught your eye, again, comment it and then we'll do a deeper, bigger video on that specifically. Next, this is really, 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 really cool. Not just blockchain stuff, but you can actually do private AI training. What that means is, let's say you have encrypted data. Let's say healthcare data. You want to train an AI on healthcare data. Well, healthcare data is encrypted, right? Everyone has their own private healthcare data. And so I don't want to give access to that data to the AI model, but the AI model might incentivize me to train it with that data anyway without revealing what it is, um, and build this kind of machine learning model based on that data. So the training data can be encrypted. We can put it into an MPC network and run a training workload on top of it. Then the output of that training workload, which is the model weights, that's what the ML model is, can also be encrypted. This is really cool because that means you can host proprietary models um, that can even be on a decentralized network. And what that means is, let's say you want to make let's say you want to have like right now, if you want to do, you want to use a proprietary model, you have to trust that the proprietary model does not have someone interfering with it from that company. I'll give an example of an LLM because I think that's what most people will understand. Although LLM type of computation isn't necessarily possible yet on Arcium, but smaller workloads like machine learning are. But let's say right now, if you want to use ChatGPT or Claude, you kind of have to rely that the Claude 4.5 or whatever the most recent um, model is the one that they're going to run when your compute runs, and that the data that they give back was actually run in that model. And you have to do that because it's a proprietary model. Well, I want to use a proprietary model, but I want to also have the security to know that Anthropic or OpenAI did not mess with the output that came out of that model, or they didn't mess with the input that went into that model. So you could take a proprietary model because it has encrypted weights, put it on a decentralized network, and then when you query it, you could run that query knowing that the model is correct and that no one could have tampered with the input and output of that model. So that's number two, model weights themselves are encrypted. And then number three, the query itself can be encrypted. And this is really cool too, because now let's say I want to ask a private question. I don't want anyone to see it. I don't want, I want to ask about my medication or any private information. I can encrypt that, send that to the model, and have it use its encrypted model weights that were trained on encrypted data um, to compute over my encrypted query. How cool is that? That is an entirely new design space that we don't even think about in blockchain. Um, but all of that is possible because of this really cool technology that Arcium is building out. So with that, I'm going to cut this video down. Um, if you have any questions, concerns, if you want to see more of these videos, if you have any specific things you want me to cover, please comment them down below. I think the next video I'm going to be doing is probably going to be a live stream developer workshop where I go into like live coding some Arcium code. Otherwise, the next structured video will probably be some Archeum specifics, how like things like Cerberus and Manticore and other MPC technologies that or other things that Archeum is doing work and how they function. Again, as always, thank you for watching. Hope you enjoyed this video and hope you learned something.